Hi students, do you know total how many distinguished tests are there in our board exam chemistry? So in overall the organic chapter, total how many the distinguishing tests are there? We have 4 organic chapter, the main verb, many distinguishing tests are there, right? Lucas test is there, Hinsberg test is there, many Carbylamine tests, many are there. So there is a confusion like which distinguished test is used for a particular question, right? So let us discuss in detail. Let's clarify that issues, everything in this video. Ready all? So total the distinguishing test, chapter wise we can discuss. First we have haloalkanes and haloarene. In the chapter haloalkanes and haloarene, mainly we have 2 distinguishing tests. They are, first one is bromine water test. So when you studying a distinguishing test, first of all we have to know that what is the main purpose of the test. So bromine water test is given by what? Here bromine water test is given by unsaturated compound, mainly unsaturated compounds. Bromine water test is given by unsaturated compound, which means what? Alkenes and all. So what is the test is, carefully, how will you distinguish between ethene and ethane? See, this is unsaturated, this is saturated. So let me take first of all ethene, right? This is what ethene we have. Let me react with what? Bromine water. What we are treating all of you? Bromine water. You know what is the color of bromine water? Bromine water having a brown color. Brown color. It's a brown color one. A reddish brown, almost a brownish color is there. So when an alkene react with the bromine water, you know what happened? This Br2, from which one Br goes to this carbon, one Br go to this carbon, we get CH2Br, CH2Br. What is that? Vicinal dihalide. You get vicinal dihalide. So when alkene react with the bromine water, it will give you a product where the product color is just what? Colorless. So we can say that when a alkene, when a unsaturated compound react with the bromine water, the brown color of that bromine water changes to what? Colorless. So if you see in this color change, brown to colorless, you can ensure that it is an unsaturated compound. What about ethane? What about ethane? If you start with the ethane, when you react with the same bromine water, dear, there is no reaction. There is no reaction. So unsaturated. So what is the purpose of bromine water test, my dear? To identify a saturated compound from an unsaturated. So it is used to distinguish between saturated compound from unsaturated compound. So unsaturated compound will react with the bromine water. The brown color becomes what? Colorless. Whereas saturated compound, no reaction. We have one more test in haloalkane chapter, that's here, silver nitrate test, AgNO3. Silver nitrate test. What is the purpose of silver nitrate test is to distinguish between haloalkane from haloarenes. Haloarene. If they given you one haloalkane along with a haloarene, you can use silver nitrate test. Just check the question all. How will you distinguish between chlorobenzene? Okay, let me take chlorobenzene. Chlorobenzene from what? Benzyl chloride. What is benzyl chloride? You know, benzene with CH2Cl is called benzyl chloride. You know, when we react with the AgNO3, silver nitrate, just a simple reaction, okay, just to understand, just I'm writing directly. So silver nitrate, when you treated with a haloarene and haloalkane. So dear all, this haloalkane, right, because halogen connected to a sp3 carbon, not on benzene. So this is haloarene, this is what a haloalkane. So haloarene, when react with the AgNO3, dear, this Ag, actually what form that compound? Ag is here. But here, no reaction. Why no reaction? You know, the removal of halogen. The removal of halogen from benzene ring is difficult, yes or no? The removal of halogen from benzene ring is difficult due to the partial double bond resonance. Yes. So, but here the removal of chlorine is easy. The chlorine and this Ag come out as what? AgCl. And why it is so? Because this Cl, when it is leaving as Cl minus, you are getting a most stable carbocation. This is benzyl carbocation. So chlorine is very easy to lose. So this, so generally haloalkane when react with the silver nitrate, the silver chloride form, and silver chloride is a white precipitate. Okay, white precipitate. So when you to a haloalkane and haloarene, when you add silver nitrate for both of them, the one which is giving a white precipitate, you can say that it is a haloalkane. There is no reaction which one, that's a haloarene. It's a basic test for which one, haloalkene and haloarene, how to distinguish. Ready? Now we can go for the chapter alcohol. So what are the distinguishing tests in haloalkanes and haloarene, my dear? That's bromine water test and silver nitrate test. Now we have alcohol, phenols and ethers. What are the distinguishing tests? We have mainly three tests. First one is Lucas test. First of all, what is Lucas reagent? We should know that is concentrated HCl and anhydrous zinc chloride, ZnCl2. That is called Lucas reagent. Lucas reagent is what, my dear? Concentrated HCl and anhydrous zinc chloride. What is the reaction actually? When a haloalkane or just alcohol, when a alcohol react with Lucas reagent. Lucas reagent means write this one on that one. Okay, you know there are three type of alcohols, right? Three type of alcohols are there: primary, secondary, tertiary. So consider it is a primary, secondary and tertiary alcohol, suppose they are using. If it is a primary alcohol, when react with the Lucas reagent, what is observation? Like a secondary and tertiary. Dear, when Lucas reagent react with a tertiary alcohol, we get a product, we get a precipitate, which is or we will get a immediate, not a precipitate like one, a turbidity form, a turbidity. So there will be a immediate turbidity. There will be a immediate turbidity. Immediate turbidity. Whereas a secondary alcohol when react with the Lucas reagent, we get a turbidity. We get a turbidity after 5 minutes. After 5 minutes, which mean which alcohol is more reactive towards Lucas reagent? Tertiary, then secondary. What about primary? Normal condition, no reaction, but it's give turbidity only by heat. Only by heat. So can you say who give more reaction towards Lucas reagent? The order we can say tertiary greater than, secondary greater than primary, like our SN1 mechanism. Follow SN1. So what is the purpose of Lucas reagent, Lucas test? To distinguish between primary, secondary, tertiary alcohol. What is observation? Tertiary alcohol give immediate turbidity, secondary alcohol give after 5 minute turbidity, whereas primary alcohol no reaction, normal condition, only by heat it can give turbidity. Question: how will you distinguish between propan-2-ol? What is propan-2-ol? Dear, this is what propan-2-ol. And what is tert-butyl alcohol? You know tert-butyl, right? This is the tert-butyl alcohol. Ready? What happened when they react with the Lucas reagent? What is Lucas reagent? Concentrated HCl and anhydrous zinc chloride. Concentrated HCl and anhydrous zinc chloride. Ready? Let's see what is observation. When secondary alcohol react with HCl, what happened? This OH and H water out, you get CH3, CH chlorine attached. You will get a haloalkane actually. Same way, here this OH remove with this H and chlorine come to the place. You will get tert-butyl alcohol. We get tert-butyl chloride. But this is the, here the turbidity. Turbidity is just like a cloudy nature will be there. A white, not a precipitate, a cloudy nature, the entire thing, solution. So what is observation? Both of them give product, but tertiary alcohol will give this turbidity immediately, but secondary alcohol give turbidity only after 5 minutes because it is lesser reactive than tertiary. So what is Lucas reagent and purpose? Clear, my dear? Lucas reagent test is, or Lucas test is used to distinguish between primary, secondary and tertiary alcohols. Ready? Now we have a special test is called neutral ferric chloride test. It is a test for special the compound phenol. Okay, all? So phenol, it's a test for phenol. This neutral ferric chloride test is given by phenol. What is the test? Take the compound phenol. Okay, now phenol is a solution. Phenol when treated with a neutral ferric chloride, FeCl3. You know what happened? Carefully listen, my dear. This, this H is acidic. So this H combined with the chlorine, what go out? HCl go out. This H plus combined with the Cl, you get HCl. What is left here? Fe, right? Fe combined with the phenoxide ion. Fe combined with the phenoxide ion around 6 times. Overall charge 3 minus, it form a complex. So when phenol react with the neutral, so while balancing and all 6Fe and all, we can write it, and 6H here will be 3HCl and actually 3H plus also go out. So generally when phenol react with the neutral ferric chloride, you get a complex. How it's getting? This H and Cl go as HCl, and the Fe combined with the Fe combined with the phenoxide ion, you will get Fe, then phenoxide ion, whole 6 times 3 minus. That will form a complex, and the complex having a violet color. This test is given by phenol. So what is the purpose of neutral ferric chloride test? If they given you a phenol with other functional group, you can choose this one. For example, how will you distinguish between phenol and ethanol? Both are alcohol, but phenol give you neutral ferric chloride test violet color, but ethanol do not. That is the purpose of neutral ferric chloride. Now we have another test is called iodoform test. Dear, iodoform test is given by alcohols with a specific group, that is CH3CHOH. If the alcohol contain this particular group CH3CHOH, they give iodoform test. Let me show you what is the test here. For example, I am taking CH3C. Let me take which one? Ethanol we can take it. Okay, ethanol. What is ethanol? I can write it as CH3CH2OH. My question, is ethanol contain this particular group or not? Can you check? Is ethanol contain this particular group? Yes, my dear. I am writing this CH3. I am writing this CH3CH2OH as like this one. So CH2 is there, CH and H. Is it correct? CH3CH2OH. Yes, it's ethanol. It contains that particular group. Which group? CH3CHOH. How to write the product? Very carefully listen. In order to get iodoform, we have to react with NaOH and iodine. Which all are there? NaOH and iodine, and we have to heat the solution. You know what happened? Dear all, if it is iodoform test, 3 things you directly write immediately. First thing is iodoform. What is iodoform? CHI3, and it is a yellow colored one. And the sodium combined with the iodine, we get sodium iodide along with the water. These are always formed in iodoform test. Which all? CHI3, that's the main thing, and what? NaI and water. Ready? How to write the last one? Carefully listen. Total how many carbon in this compound, my dear? 2 carbon, right? 2 carbon is the alcohol. Among that, 1 carbon already we written in the iodoform. How many carbon left? 1 more carbon left. What is 1 carbon contains sodium salt of acid? That is HCOONA, sodium methanovate. So what is the purpose of iodoform test, my dear? If the alcohol contains CH3CHOH group, they can give iodoform test a yellow color. For to get iodoform, what we have to treat? Take your compound, react with the NaOH and iodine and heat. You get three things directly: iodoform, NaI and H2O. And how to write the remaining product? Total how many carbon you check in the compound? One carbon already there in iodoform. So remaining how many carbon? It's sodium salt of acid, you write it. Ready all? So question, how will you distinguish between ethanol and propanol? Ethanol we just mentioned like this one. Have you seen? Ethanol we can write like this. Yes. What about propanol? CH3, CH2, CH2OH. Dear, ethanol contain that group, but propanol do not. Exactly that group should be there, okay? CH3, CHOH. So tell me dear, what are the three distinguishing tests in which one? Alcohol chapter. Lucas test, neutral ferric chloride test and iodoform test. Lucas test is used to distinguish between primary, secondary, tertiary alcohol by checking the turbidity. Neutral ferric chloride, the yellow complex, the violet colored complex is given by only phenol. And the iodoform test is given by the alcohol with this group, yellow colored iodoform. Now we are going to the chapter aldehydes, ketones and carboxylic acid. Around 5 distinguishing tests we have to study, my dear. 2,4-DNP. What is the full form? 2,4-dinitrophenylhydrazine. 2,4-dinitrophenylhydrazine. All of you note it all. This test is given by all aldehydes and ketones. So you should know what is the test and who give this test. 2,4-DNP test is given by all aldehydes and all ketones. What is the test? Take your aldehyde and ketone. Okay, it can be any aldehyde or ketone. Let me react with what is 2,4-DNP structure? Come on, my dear. You studied in chapter, right? What is NH2, NH, and then a phenyl ring? This is called phenylhydrazine. Where second and fourth position to nitro group. This is called 2,4-dinitrophenylhydrazine. What is the reaction? Very simple. Take the oxygen from the aldehyde ketone, take the H2 from the compound, remove water, join them. C double bond, N, NH, then there is a phenyl ring. Second and fourth position we have 2 nitro group. The product is called 2,4-dinitrophenylhydrazone. Phenylhydrazone. So 2,4-dinitrophenylhydrazine become 2,4-dinitrophenylhydrazone. You know what is the color, my dear? It's having a orange yellow color. It's having a orange yellow color. So if you are getting a orange yellow color when aldehydes and ketone react with the 2,4-DNP, if you are getting a orange yellow color, you can confirm it's an aldehyde or ketone. For example, how will you distinguish between propanol and propanoic acid? Propanol is an aldehyde, right? Yes, aldehyde give this test, whereas acid do not. Let me write the structure of propanol. What is propanol? CH3, CH2, CH double bond O. Yes or no? This is propanol. How you write the reaction? All NH2, NH, and the phenyl compound is there. NO2, properly draw. Okay, the structure of benzene and all. Ready? Okay, we have phenyl, NO2. How we write the product, all of you? Cut the oxygen, cut the H2, join them. You get CH3, CH2, CH, double bond. What is left here? N, NH, and there is a phenyl ring, and we have NO2. Ready? Clear? You will get a orange yellow colored precipitate. So what is 2,4-DNP and what is the purpose? 2,4-DNP test is given by all aldehydes and ketone. Study the reaction here. Okay, next one, Tollens test. Tollens test is also known as what? Silver mirror test, right? Silver mirror test. Tollens test is also called what? Silver mirror test. What is Tollens reagent first of all? Tollens reagent is ammoniacal silver nitrate, AgNH3 twice plus. This is what Tollens reagent. What is Tollens reagent, all of you? Ammoniacal silver nitrate. It's a coordination complex, AgNH3 twice plus. What is the reaction and who give this test? All of you study. This test is given by all aldehydes. This test is given by all aldehydes. Okay, this Tollens test is given by all aldehydes, including aliphatic and aromatic. For example, what is the test? Let me take a aldehyde, for example, RCHO. Any aldehyde, okay? Aliphatic or aromatic. Treat with the Tollens reagent. What is Tollens reagent? We have AgNH3 twice the whole plus. Okay, so in a test tube, first take the aldehyde solution, to which add is ammoniacal silver nitrate, Tollens reagent, along with a base OH minus and heat. You know what happened? Carefully listen, very simple. Tollens reagent is an oxidizing agent. Tollens reagent is an oxidizing agent. So, you know, aldehyde on oxidation become acid. So, RCHO become RCOO. Don't write COOH completely. Anyway, it forms salt, means acid, plus that H combined with the OH, we can write what? H2O. And the complex break, you will get Ag and ammonia. This Ag will deposit. What is Ag? Silver, right? Silver get deposited on the side of the test tube, exists as a mirror. Therefore, it's called silver mirror test. Once again, what is Tollens reagent, my dear? Ammoniacal silver nitrate is called Tollens reagent. Who give this test, all of you? All aldehydes like aliphatic and aromatic. What is a test? Take a test tube, first add aldehyde, then add Tollens reagent, add a little bit base and heat them. What is the observation? Heat, okay, heat is there, heat them. What is observation? You know, what is observation? The Tollens reagent is an oxidizing agent. So it oxidizes the aldehyde to acid. Along with that, always what is the byproduct? Silver, ammonia and water. The silver get deposited on the side of the test tube. Therefore, it's called silver mirror test. Question: how will you distinguish between butanol and butan-2-ol? Butanol is an aldehyde, butan-2-ol is a ketone. This test is only given by aldehyde, so we can go with this one. What is butanol? It's compulsory to write the reaction during exam, my dear. This is what butanol, right? Butanol. Butanol, when react with AgNH3 twice the whole plus with base and heat, what happened? The aldehyde becomes salt, the acid. So it becomes CH3, CH2, CH2, COO minus. Byproduct always same dear, H2O, silver and ammonia. Clear what is that? So whereas ketone do not respond this test. Means when you're doing a distinction test, one should give, one should not. Ready? Next we have Fehling's test. Dear, Fehling's test is given by only aliphatic aldehydes. Only aliphatic aldehydes. Ready? What is Fehling solution? You have Fehling solution. In order to do Tollens test, we are doing Tollens reagent, right? If you want Fehling's test, we have to take Fehling solution. There are two solutions, my dear. Fehling solution A and we have Fehling solution B. We have two Fehling solution, both of them we have to use in equal amount for the reaction. What is Fehling solution A? Fehling solution A is copper sulfate 5H2O and its color is, you know, blue color. Fehling solution A bottle, if you check it, it's a blue color because it's copper sulfate 5H2O. Fehling solution B is sodium and potassium salt of tartaric acid. Sodium and potassium tartrate. It's also called Rochelle salt. So what is that, my dear? Fehling solution A is blue color because it's copper sulfate 5H2O, whereas Fehling solution B is sodium and potassium tartrate, and it's also called Rochelle salt, and it is colorless. But don't worry. When you're writing the overall Fehling solution A and B together, you have to write a simple term. For example, let me take a aldehyde, all of you. Which aldehyde? Only aliphatic, okay? Aliphatic aldehyde is ready. Mix with, first add Fehling's A and Fehling's B. Fehling's A, Fehling's B, overall when you add, what is the reagent? CuO. Reactant is copper oxide. What is that? Copper oxide. So Fehling's A, Fehling's B, overall when you add, what you have to write? Copper oxide. Here also we need a base OH minus and heat. You know what happened? The aldehyde, even Fehling solution also an oxidizing agent. So copper oxide, it's an oxidizing agent. Fehling solution is also an oxidizing agent. So aldehyde become acid, RCOO minus. And that H, COOH, that H combined with OH we get H2O, and copper oxide become Cu2O, that's called cuprous oxide. What is that, my dear? Copper oxide become cuprous oxide and its color is reddish brown. What is that? Reddish brown. A blood brownish color will be there, reddish brown. So when you take a aldehyde, which aldehyde? Aliphatic aldehyde, to which when you add fillings A and fillings B in equal amount, copper oxide will be there, and along with a base and heat, you can see the blue colored solution that changes to what? Reddish brown in color. That's what Fehling's test. Copper oxide become cuprous oxide. Question: how will you distinguish between propanol and benzaldehyde? Propanol is an aliphatic aldehyde. Benzaldehyde is an aromatic aldehyde. Aliphatic aldehyde give only Fehling's test. So let me take it. Propanol. How you write the reaction? All propanol is CH3, CH2, CHO. Mix with your copper oxide, that is our Tollens reagent, along with the base and heat. The aldehyde become acid. So CH3, CH2, COO minus. What is the byproduct always? H2O and cuprous oxide here. That's reddish brown color will be there. Clear? So Tollens test is given by all aldehydes and all aldehydes, which mean aliphatic and aromatic. But Fehling's test is given by what? Only aliphatic. Careful. We have one more, iodoform test. We discussed already iodoform test in alcohol, right? Where they give the compound which contains CH3CHOH, right? Dear, iodoform test is given by aldehydes and ketones also with a specific group CH3C double bond O. If it is an alcohol, it must contain this group. If it is an aldehyde or ketone, it must contain this group. What is the test? Already we discussed before. Take your compound, for example, I am taking propanol. What is this all? Propanol. Propanol is there. Can it give this test? Yes, because it contains that CH3CO group. What is the test to get iodoform? Treat with NaOH and iodine. Heat. I told you the three products always we can write in iodoform test is there. Which all? CHI3. What is CHI3 called? Iodoform. What is iodoform color? Yellow color. And do you remember the byproducts all? Na combined with the iodine, we get NaI along with the H2O. These three things blindly write. If it is iodoform test, write iodoform, water and NaI directly. What is the last? Total how many carbon in your reactant? 3. Among that 3, only one you've written in which one? Iodoform. So 2 carbon missing, right? So 2 carbon acid is what? CH3COONA. That's all. So iodoform test is there in alcohol chapter, even in our aldehyde chapter. If it is an alcohol, it must contain this group. If it is an aldehyde or ketone, it must contain this group. Clear, everyone? So question, how will you distinguish between pentan 2-on and pentan 3-on? Dear, pentan 2-on means this one. Ready? This is what pentan 2-on. What about pentan 3-on? CH3, CH2, C double bond O, CH2, CH3. Who give iodoform test? Come on. This pentan 2-on because it contains that group. Okay, what is the reaction? Take NaOH and iodine, then heat. What happened here? Blindly write the first 3. CHI3, NaI and H2O is common plus. How to write the last? Total 1, 2, 3, 4, 5. 5 carbon in this compound, only 1 carbon in the product. So 4 carbon missing, right? So write 4 carbon acid. Which one? CH3, CH2, CH2, COONA. Clear, dear? We have one more test in this chapter, sodium bicarbonate test. It's also called NaHCO3 test. This test is given by all carboxylic acid. This test is given by all carboxylic acid. What is the test? Take a acid, carboxylic acid, and add sodium bicarbonate, NaHCO3. You know, when acid react with the metal hydrogen carbonate, you will get salt, water and carbon dioxide. What is the salt? RCOO, Na plus H2O and carbon dioxide. You know this carbon dioxide, comes as bubble, it's called brisk effervescence. So what is the test, all of you? Any carboxylic acid, when you mix with the sodium bicarbonate, you will get brisk effervescence of what? Carbon dioxide, which indicate it is a carboxylic acid. Question, how will you distinguish between ethanoic acid and ethanol? It's an acid. Acid give this test, aldehyde do not. What is the test? Take your ethanoic acid, CH3COOH, and mix with the sodium bicarbonate, dear. What happened? The salt form CH3COONA along with the H2O and carbon dioxide gas start to generate. That's it. So total 5 distinguishing tests in aldehydes and ketone parts here. 2,4-DNP test. It's given by all aldehydes and ketone. Observation orange yellow. And the Tollens test is given by all aldehydes, aliphatic and aromatic, silver mirror. And the Fehling's test is given by only aliphatic aldehyde, that copper oxide become reddish brown cuprous oxide. And Iodoform test is given by aldehydes and ketone with this group yellow color. And the sodium bicarbonate test is given by all carboxylic acid, brisk effervescence. Now we have the last chapter, amines. Here also we have around 3 to 4 distinguishing tests. One is called Hinsberg test. Dear, Hinsberg test is used to distinguish between primary, secondary and tertiary amine. Hinsberg test is used to distinguish between primary, secondary and tertiary amine. What is the test and all? Let us just discuss in brief. Dear, what is Hinsberg reagent? I am taking the Hinsberg reagent. The Hinsberg reagent is, I am writing that Hinsberg reagent, benzene sulfonyl chloride. This is called Hinsberg reagent. What is that? Benzene sulfonyl chloride. So I am taking, this is one Hinsberg reagent. Now let me take another Hinsberg reagent. Okay. Another Hinsberg reagent. Now let me take one more Hinsberg reagent. Ready. Why 3 Hinsberg reagent? To react with the primary, secondary, tertiary, all amine. Let me take a primary amine first. Primary amine, let me write RNH2, or let me write like RNH2. Ready? And this is a primary amine. Now let me take a secondary amine, RNRH, and tertiary amine, RNRR. Ready, dear? When you react with the Hinsberg reagent, do you want to see what's happened? Carefully listen. Carefully listen. You know what happened? This H and Cl cut. This H and Cl cut. What do you get the product? RNH, S double bond O, and then we have benzene ring. What it is called? It's called N-alkyl, where N contain one alkyl group, right? N-alkyl benzene sulfonamide. When a primary amine react with a Hinsberg reagent, what is the product called here? N-alkyl benzene sulfonamide. Now, here also what happened? The HCl cut, you get RNR, S double bond O, and the benzene ring. What it is called? N-dialkyl benzene sulfonamide. But here no hydrogen to react, so tertiary amine, no reaction. So dear, what is observation? Tertiary amine do not react with the Hinsberg reagent, whereas primary amine and secondary amine, both of them react. So how you understand these two is which is the product? Have you seen there is a hydrogen? Have you seen there is a hydrogen in the primary amine reacted product? This hydrogen is acidic, dear. This hydrogen is acidic. Therefore, this compound, this precipitate is soluble in alkali. Why it is soluble in alkali? Because it having an acidic hydrogen. Such a acidic hydrogen is not here. Therefore, the secondary amine reacted product is insoluble in alkali. Insoluble in alkali. That's a difference. So, primary amine react with the Hinsberg, we get a product which is soluble in alkali. Secondary amine react with Hinsberg, we get a product which is insoluble in alkali. Tertiary amine do not react with the Hinsberg. So question, how will you distinguish between ethyl amine? What is ethyl amine? C2H5NH2, ethyl amine, from diethyl amine. What is diethyl amine? C2H5NH, C2H5, diethyl amine. You know, it is a primary amine, it is a secondary amine. Same way react with Hinsberg, you get a product here which is soluble in alkali. this also react with the Hinsberg, you get a product which is insoluble in alkali. That is the observation. So what is the purpose of Hinsberg test here? To distinguish between primary, secondary and tertiary amine. Let's go for the second one called Carbylamine test, is also known as isocyanide test. Carbylamine test or isocyanide test. Note it all. This test is given by primary aliphatic and aromatic amines. This test is given by primary aliphatic and primary aromatic amine. For example, carefully listen. I'm taking a primary, general reaction, let me write, okay? RNH2. What is RNH2 mean? A primary amine. Maybe aliphatic or aromatic, we can use it, okay? First react with the chloroform. What is chloroform? CHCl3 along with what? Alcoholic KOH and heat. What's happening here? When a primary amine react with the chloroform and alcoholic KOH, the amine become isocyanide. What is isocyanide? RNC. Therefore, this test is called isocyanide test. You know the byproduct always same. The K combined with the Cl, we get KCl along with the what? H2O. And what is observation? The isocyanide having very foul smell. So if you are getting a foul smell when react with the chloroform and alcoholic KOH, you can confirm that it's a primary amine, maybe aliphatic or aromatic. Example, how will you distinguish between aniline? What is aniline? Benzene with NH2, aniline with NN dimethyl aniline. What is NN dimethyl aniline? On nitrogen there are 2 methyl group, right? You know it is a primary aromatic amine. This is a tertiary aromatic amine. Yes or no? Primary aromatic amine when react with the chloroform and alcoholic KOH and heat, what happen? NH2 become NC, isocyanide with a foul smell along the byproduct what? KCl and H2O. Ready all? Whereas tertiary amine, no reaction. So carbylamine test is also called what? Isocyanide test. Okay, this test is given by only primary aliphatic and aromatic amine. Now we have nitrous acid test. What is nitrous acid? HNO2, nitrous acid. See all, let me take it. So what is the purpose of this test is to distinguish between aliphatic amine from aromatic amine. If they given you one aliphatic amine, one aromatic amine, we can use nitrous acid test. Do you want to see what is the test? Check it all of you. First, let me take a aliphatic amine. This is an aliphatic. Amine when react with nitrous acid. You know what is nitrous acid? HNO2, nitrous acid. You know what happened? Then NH2 become N2Cl. It become alkyl diazonium salt. Right? It will form alkyl diazonium salt. Ready. Now, this it is highly unstable. This alkyl diazonium salt is highly unstable because no resonance and all, nothing, no resonance stabilizing factor here. So, it immediately react with the water in the medium. What all the ions present in water? H plus and OH minus, right? So this H and Cl combine, HCl out. The nitrogen gas come out. What is left? R with OH. What is ROH mean? Alcohol. You know, alcohol having a sweet smell. So when primary aliphatic amine react with the nitrous acid, you get a unstable salt which is immediately react with the water, form a sweet smell what? Alcohol. Whereas if it is an aromatic amine, for example, let me take it aniline. If it is aromatic amine like aniline, when react with the nitrous acid at 0 to 5 degrees Celsius, what happen? NH2 become N2Cl. What it is called? Benzene diazonium chloride, right? You know the name and all. Benzene diazonium chloride. It is highly stable. It is highly stable. So what? It immediately do not react with water and form alcohol. That's observation. So what is the purpose of nitrous acid test? To distinguish between aliphatic amine from aromatic amine. Aliphatic amine react with the nitrous acid, give you a product which give you a salt which is unstable, immediately react with the water, form alcohol, a sweet smell. Whereas aromatic amine react with the nitrous acid, you get a salt which is highly stable, so do not give alcohol immediately. Now we have last one more test, azo dye test. Some color dyes will form. This is a special test for aniline. Okay, all. Do you remember? Phenol, we have a special test, neutral ferric chloride, the violet color complex. Same way, aniline, the test is called azo dye test. For example, how will you distinguish between aniline and ethanamine? Aniline, if they given, you can use which one? Azo dye test. What is the test is? Take a diazonium salt. You know what is diazonium salt? Benzene, N2Cl. This one, benzene diazonium chloride. The benzene diazonium chloride I written here, N2 means NN triple bond. The benzene diazonium chloride when react with the aniline, aniline is what? Benzene with NH2. Since aniline is basic, we are using a acidic medium here. You know what is the reaction? From the para position of aniline, let me take one H. This H and Cl, HCl out. So what is left in the system? This benzene with N triple bond, N becomes N double bond, N, again one benzene with what? NH2. The name of the compound is para-amino. The entire compound is called azobenzene. Para-amino, azobenzene. Para position amine, the entire thing is called which one? Azobenzene. Okay, para amino azobenzene. It's having a yellow color. It's a yellow dye. So aniline, if you want to distinguish, just to treat with the benzene diazonium chloride in acidic medium, it will give you a yellow dye. These are the distinguishing test in which chapter? Amines. So once again everyone, what are the distinguishing test in amine chapter? Hinsberg. This test is to use to distinguish between primary, secondary, tertiary amine. Now we have carbylamine test or isocyanate test. This test is given by only primary aliphatic and aromatic amine, foul smell. Then we have nitrous acid test to distinguish aliphatic amine from aromatic amine. Then we have azo dye test, a special test for which one? That's aniline. Now total we have, so haloalkane, haloarene chapter we have bromine water test and this silver nitrate test. Alcohol, phenol, ether, 3 distinguishing, which all? Lucas test, then we have neutral ferric chloride test and iodoform test. In aldehyde chapter, we have 5 distinguishing, 2,4-DNP, Tollens test, Fehling's test, then iodoform test and sodium bicarbonate test. In the amine chapter, we have 4 distinguishing tests, Hinsberg test, Carbylamine test, nitrous acid test and azo dye test. So keep practicing. So all the distinguishing tests are there in this chapter. Definitely for board exam, you can expect the any of the distinguishing tests from any of the chapter. So keep practicing, focus on the topic. A specific test is used for which reagent, which compound. Okay, this if they given you distinguish between these two compound mean what they given and which chapter, which all reactions are there, which one is applicable, and write the reactions also. All the best.